In this series, I'll show you how to create smooth math and modeling-based animations for Minecraft Bedrock add-ons using Blockbench, without drowning in complicated math language. We'll go from opening Blockbench all the way to spawning your custom mob into your own Minecraft world so your friends can join and see it in action. In this first episode, we're building a copper clockwork squirrel you can drop into your world and show off. First, open Blockbench. If you don't have it installed or need help setting it up, I recommend Arts by Kev's guide. Next, grab some reference art. You can follow along with the doodle reference I made, find something online, or sketch your own. It doesn't have to be perfect, it just needs to guide your proportions. Now start a new custom entity. File, New, Minecraft Entity Wizard. For this project, we'll use a basic template. Give your entity a display name and a namespaced identifier. Since we'll be implementing our own behaviors and logic later, choose Basic Still for appearance, Basic Walking for behavior. For custom loot during prototyping, I usually make mobs drop a single emerald. It's simple and easy to test. Pick spawn egg colors, or design your own if you want something more modern looking. Set export to folder, name your add-on, sign it with your author name, then click Export and Edit Model. Next, we need to delete some of the generated elements. The generated texture, the root cube inside the root group. Right-click in the workspace and add your reference image, either from clipboard or by importing. Make sure Show Grid and Pixel Grid are enabled. Switch to Solid Shading View. It makes design and debugging much easier. Now, we're ready to build. Begin with a new cube within the root group, name it Head, and size it to 4x4x4. Shortcut, press S to switch to resize mode, and then hold Alt to resize uniformly. Next, enable mirror modeling so we can cut half the work out. Next, add a 1x1x1 cube to the top of the head for the left ear. Mirror modeling should add the right ear automatically. See? Half the work gone with a simple mirrors trick. Duplicate the head cube, rename it to Face. Shortcut, F2 to rename. See even more efficiency popping up like magic. Resize it to 4x2x1 at the front of the face. It should start to look like a cute little snout now. Now we need the nose. Duplicate the face cube and rename. Then resize it to 2x1x1 and then move it a little up and out from the face. Shortcut, V key switches to move mode. Now we're really making all that tedious mouse work disappear. Next, we add the little chompers. Duplicate the face, name it Teeth, resize to 1x1x0. Group together the head, face, teeth, nose, left ear, and right ear, and we'll call the group Head. Duplicate the head cube and move it out to the root group, then name it Body. Resize the body to 4x4x8, and then move it down and back from the head group. Group the body cube into a body group and move the head group into the body group. We should have something resembling a little hamster, now to transform it into a squirrel. Now we want to group the body cube again into its own middle body group. This makes doing organic animations easier later on. Duplicate the body, name it Tail Base, resize it to 4x8x4, and position it at the back of the body. Now duplicate the tail base so we can create the tail tip. Resize the tail tip to 4x4x4 and move it to the top backside of the tail base. Now we need to pivot points and set pivot points before grouping the next cubes. Select the tail base and position its pivot point to a spot that overlaps the tail base and body. Shortcut, P key switches to pivot tool. Now we're tool switching like a magician doing sleight of hand. And then group the tail base. Now for the tail tip, adjust its pivot point to be the point where the base and tip cubes meet. Then group the tail tip and move the new group inside of the tail base group. Now we need to give the little guy some getaway sticks. Duplicate the body and move the new cube to the front right leg position. Size it to 1x3x1 and slightly inset into the body. Gives the illusion of extra depth without mixing pixel density and textures. Poof, magic. Now we need to set the pivot points and group each individual leg. Pivot points should be where the logical joint is for the bones. Move the head group and the tail base group into the middle body group. Select the body group and center our model. Finally, inflate just the head cube by 0.25 and inflate just the body cube by 0.125. Now we move on to adding a coat of paint. Turn off modeling mode first, or setting up the texture will not go as planned. Switch to Paint View, turn on Textured View, and create a new texture. Shortcut, Ctrl+Shift+T. This one's useful to remember when adding texture variations. Set the name to match the mob identifier. Create a palette of around 10 shades of a copper color and begin painting that texture. I like to do a base coat on all the elements first, and then go through and do pixel painting afterward. For this squirrel, I want it to look like a copper construct, but still fit into the cozy companion type vibe. But This is the part where you can be creative. Maybe you want a squirrel that's made out of sweets, or a mutant radioactive squirrel that has a green glow all over. Doesn't really matter what your attempt looks like at this point. This is the creative part, and this wasn't my first attempt by any means. Now that the main texture is done, let's duplicate the base texture for a new eyes overlay. This will be used to make the eyes glow later on. Color in where the pupils would be, select the inverse of those pixels. Shortcut combo, M switches to Selection tool in Paint View, and Ctrl+I inverts the current selection, and delete the unneeded parts of the texture. Save the new textures into the Entity Textures directory for your add-on. Create new materials for both the base texture and the eyes texture. Next, we need to create the materials. For the eyes, we just need an emission value with the output range limited to around 128. For the base texture, we'll do roughness with the output range at 64, and then do metalness at 96. Alright, that's it for texturing. Now moving on to animating, switch over to Animate View. Let's start with a basic idle animation. Add animation and name it appropriately. First, we'll give it a breathing up-down motion. Select the middle body group and add a keyframe for position. Now for the math part, for the Y position value at keyframe 0, we want to add something like math.sine open parenthesis query.anim_time times 90 close parenthesis times 0.125. When played, the body, head, and tail should smoothly move up and down. Next, let's make the tail swish back and forth a bit. Select the tail base and add a rotation keyframe at 0. We want this to rotate about 5 degrees on the Z-axis, back and forth a bit faster than the breathing up-down motion. So let's go with math.sine open parenthesis query.anim_time times 180 close parenthesis times 5. That's looking pretty good for idle. Now we can move on to a basic walk cycle. Create a new animation and name it accordingly. But this time, set the anim time update to query.modified_distance_moved. Alright, next is the most complex the math gets for this video, but it still isn't much more complex than the breathing animation. I just picked some random numbers that fit right, so feel free to adjust the numbers for your model. Left front leg needs to move up, down, and front back. For up, down, we can do math.max open parenthesis 0, comma math.cos open parenthesis query.anim_time times 76.34 close parenthesis. An easy way to remember 76.34 is that 3 plus 4 is 7, so 767. This makes the leg move up smoothly, but prevents the foot from stepping through the ground. Next, we do the front-back animation using sine instead of cosine, like this. Math.sine open parenthesis query.anim_time times 76.34 plus 180 close parenthesis. Now for left-back leg, we want it mirroring what the front leg does. So we set its Y keyframe property as math.max open parenthesis 0, comma math.cos open parenthesis query.anim_time times 76.34 plus 180 close parenthesis, and its Z property to math.sine open parenthesis query.anim_time times 76.34 close parenthesis. That's the left side all done. Now we can copy/paste those keyframes to their partner leg pairs. Front left leg maps to the rear right leg, and the rear left leg maps to the front right leg. So just copy and paste the keyframes to their corresponding partner legs. Finally, add one more rotation keyframe to the middle body group, and set it to rotate along the Z-axis, with math.sine open parenthesis query.anim_time times 76.34 close parenthesis times 5. This gives the whole body a little more organic life when it walks now. Save the two animations within our add-ons animations folder, and that's it for math and creating the animations. Next, we go over setting up an animation controller for our new mob. Now for the animation controller, give it a simple name like General or Basic, since we will only use it for basic animations. Blockbench provides a controller preset for walking. We'll just use that for now. For the idle state, set the animations to use idle, and for the walking state, set the animations to use walk. Everything else is already done for us. Next, we save the animation controller into our add-ons animation_controllers folder. At this point, our custom mob should be spawnable thanks to Minecraft Entity Wizard, but we need to fix several of the add-ons files before it's fully functional. The first file that we should update is the client-side entity file within the resource pack folder. we need to add in the eyes overlay texture support. Minecraft already provides a way to implement the glowing eyes thanks to the copper golem, so we'll use that method to keep things simple. We need to update materials, textures, and render underscore controllers. After getting the textures linked properly, we need to add in our animations. We need idle and walk animations plus the general controller. Finally, we need to create a render controller for our entity for both its base texture and the eyes texture. The base texture can use default vanilla-like values. For the eyes texture, we mimic the same render controller as the copper golem while adding ignore lighting equals true. Finally, we can load Minecraft and activate our resource and behavior pack on your world or a realm. Now that you can raise an army of mechanical squirrels, what kind of pranks can you think of doing with them?